Hey guys, how are you all doing this week? So as you know from my message and not seeing any lessons the last 2 days, you're just going to be getting one from me every week, one per week from now on. This is the way Putnam County Schools wants us to do it. I was going to keep going with this class since it's dual credit, but they said any high school credit or dual credit courses need to follow their schedule. So we're going to do exactly what they tell us to do. That means every Wednesday you're going to be getting an assignment from me. So you'll still get the same video lesson, maybe a little bit longer, but it shouldn't be too bad. Also, next week is spring break, so you will not be getting anything next week. That again is spring break, and you will not be getting anything from me next week. We're still following that. Okay, so the lesson that we're going to do today was going to be my next lesson that we would have done Monday. And if I would have known we were going to this one lesson per week format, I would have lumped it in with Friday's lesson, because Friday we talked about solving basic exponential equations, and then today we're going to talk about solving more intense exponential equations. So everything on Friday that we did, we chose one of two methods. We either equated the bases, so this is under things from last week right here. We either equated the bases or we changed the equation over into log form, which made the problem easier for us, and we could just calculate one side of it, and it outputted us an answer. Okay, so some of the things that we're going to do today, those aren't going to be an option. Okay, so we might have a problem, just say for instance, we might have like 5 to the power of x equals 7. Okay, you can't equate the bases on something like that, and changing it over to log form is not really going to be very useful to us. Okay, so on that one you could really transform it over to log form, but this is the situation where more than likely what would happen is you'd have like 5 to the x on the left and 7 to the x plus 2 on the right. Okay, turning that over into log form is a no-go because you've got exponents with variables in both sides and you can't really do anything with it. Okay, so there are reasons that we will not be able to either equate the bases or change over into log form. So our new option, if we can't get any of that to work, is to log both sides. Log both sides, okay? So as we go through these examples, on a few of them, I'm going to log both sides. And we can't just whip a random log in there. What we want to do is keep our inverse identities in mind. We talked about inverse identities early last week. If you don't remember those, take a look at that video again. So we want to keep our inverse identities in mind and choose a log that works best for our situation. Okay, so taking a look at example 1 here. Before I do anything, I've got to get my base with the exponent by itself. So my base with the exponent here being e to the 2x, okay? 4 needs to leave and 3 really needs to leave before I start this problem. So I'm going to take 3 over to the other side. That would give me 4e to the 2x is 5. And then 4 needs to leave. Okay, so that would be e to the 2x is now 5 over 4. Now, I can't equate these bases because I can't make e to some power, something like that. And I definitely can't make like 5/4 equal out to be an e to something. It's just not going to work, okay? So for this reason, this is why I need to log both sides, okay? So what I'm going to do is choose the log that has the same base as my base number of the exponent. So I want my log to have base e. And if you remember, there is a log that has base e. That's natural log, okay? So I'm going to natural log both sides. Why am I allowed to do this? Because if I can do anything to either side, I can add pizza to both sides if I really want to, and it's not going to change the problem as long as I do it to both sides. Okay, so keep in mind there is a little base e right here, and according to your inverse identities, all of this is allowed to go away if the base number and the whole size number are the same, just leaving you with what you had left on the left, or in the exponent. So I've got 2x is equal to the natural log of 5 over 4. I don't know what that is yet. Don't really care because I don't want to type it in yet because I would lose some of my decimal. Okay, so the only thing I got left to do, just get rid of the 2. And that will output me whatever x is. I'm going to type that in my calculator. So I'm going to say the natural log of 5/4. And then I am going to divide that all by 2. It gave me 0.11. Let me make sure that's right because something does not seem right about that. Yep, 0.11. That's what the book got to. Seems like a silly number for them to get for one of their first examples on this topic, but that's okay. It is what it is. Okay? So 0.11 would be our answer on this question. Okay? Let's move over to example 2. Again, I want to get everything by itself. I want to get my base of the exponent with the exponent part by itself. So essentially in this problem, I need to get the parentheses by itself. So 4 needs to leave. So let's add 4. That gives me 2 times 3 to the 2x minus 5 is equal to 15. And then if I divide by 2, I've got 3 to the power of 2x minus 5 is 15 over 2. Now, I cannot equate these bases. I could turn it over in a log form. I'm not a big fan of turning it over in a log form because what we run into in time is problems that have exponents on both sides in the with variable exponents. Not very many of our problems have it. Actually, it doesn't look like any of our, down toward the bottom, they have it. The old book used to have some problems like this, and it comes up more often than you will realize. So like moving forward, they probably will come up. So I am a big fan of just logging both sides. So the way that I want to log this left side is to get my variable out of the exponent. That's my goal. I need 2x minus 5 to be down at normal height. So if I choose the log with a base 3 of 3 to the 2x minus 5, I've got two ways of going at this. Let me do it to the other side. I got two ways of going at this. I can take the exponent, move it to the front, and then divide this whole thing over. Or I can just recognize that this whole thing goes away, just leaving me with 2x minus 5, and then the right side is log base 3 of 15 over 2. Okay, at this point I've just got to add 5. And then that'll give me 2x is log base 3 of 15 over 2, and I'm adding 5 to it. Then I just got to divide the 2 off. So x will be, let me type that in. It looks like, so log base 3. If you don't have a calculator that'll do that, you have to do the change of base formula. That's not a big deal for you. You should be able to handle that. And I'm adding 5 to it and then dividing by 2. It gave me 3.417. So let's go 3.42. Okay, there is my answer. Let me give you a little dividing line there so you know where that problem ends. All right, 3.42 outputs us our x value on that problem. Ooh. Let's do 2 more. 3 is an intense problem here, okay? You've got multiple e to the x's. What I want you to notice here is a quadratic look to this problem. The front part is something squared, because it's to the 2x. The middle is something to the regular x. And then the end is just a regular number. So basically, what you have to do is pretend that the e to the x is the x itself. So what this actually says is x squared minus 3x plus 2. Okay, and you know that would factor into x, 2, 1, both minus. Okay, but the issue is it was not x squared and negative 3x. It was not those. It was e to the x squared and e to the x times negative 3. Okay, so what really our problem here is e to the x minus 2 times e to the x minus 1. So you can factor these just like you would a regular quadratic. If you struggled on what I was saying here, e to the x squared is the same thing as the first part right there. Okay, so that might make it a little bit easier for you to see. From here, set them both equal to 0. They both get their own, so e to the x minus 2 is 0, e to the x minus 1 is 0, and we'll just solve them both. The problem here is we've got e to the x equals 2. What can we do? Well, we can natural log both sides because that's a little base e, and it makes all this go away to just give you x. That would be the natural log of 2. We can get the decimal for that in a minute. Add 1. Whoa, holy cow. Hold on, let me get you to rein back in here. All right, I don't know what happened. So let's add 1. So e to the x is 1, and we'll natural log both sides again. All right, so that leaves us with x equals natural log of 1. I didn't write my natural logs here, but it'll be okay. Natural log of 2 is 0.69. Natural log of 1 is 0. All right, so this outputs you 2 answers. Last problem over here, example 4. This one really is much easier than you would expect it to be, okay? And I have talked about logging both sides throughout this whole process. I can still log both sides on this one, okay? I'm going to choose natural log. So I got e to the negative 2x, natural log of e to the x squared minus 2x. And then this goes away. This goes away. Basically leaves me with negative 2x on the left and x squared minus 2x. I think I have this problem written down wrong. Let me check real quick. Yeah, here. Fix this problem. All right, up here in the original, this is supposed to be e to the negative x squared. All right, I chose this problem for a reason because I wanted to show you something, and then I wrote it down wrong. So this is negative x squared, which means this is negative x squared. Okay, so the exponential part of this problem is very easy. Logging both sides makes it all go away, and then you're just working with the x's and the exponent. And then you may be panicked. You're like, oh my gosh, I don't know what to do. But you know how to factor, okay? And you know how to solve quadratic equations because we've done it 1,000 times. Put everything on the same side, so add x squared. So you get 0 is 2x squared minus 2x, and you know the first rule factoring is factor out of GCF. So you got 2x times x minus 1. That's all equal to 0. Everything gets its own 0. And we'll solve them very simply. So x is 0 here. And x is 1 there. So you'll output 2 answers on that one as well. Okay? So I really think you should be okay with this. Like I said, we would have done this on Monday's lesson. And if I would have known we were doing this once a week deal, let me try to get this out to where you can see everything. Ooh, that's too far. If I'd have known we were going to do this once a week deal, we would have lumped this in with Friday's lesson. Okay, so if you need to be able to see everything, here you go. You can take a screenshot of this if you need. Today we are going to work on page 218. I actually let Faith, Hope, Love, and Joy do the bartering instead of Eli today, and she got you a really good deal, 55 through 76. She's been dying to make a deal. She knows she thinks Eli is subpar at deal making, and then when Sam gets in on it, it's just a disaster. So she got you a really good deal today. Work through these, and then as you know, you've got a week to turn it in. So next Wednesday, you'll have to have it in by then. I just go ahead and do it. It's really not that bad. Okay, so I hope you do well with this. Like I said, I will not talk to you next week because next week is spring break, so you'll hear from me again in 2 weeks. All right, so I hope you guys are doing well. Miss you all. Hope to see you again soon back at school, but hard to tell what's going to happen. So let me know if you need anything. Send over a message. Even if you just want to say hi, do whatever you got to do. Okay, I'll see you guys.